We're going to go from the basics here to something a little more advanced. What I want to accomplish today is incorporating sound, though we will do that last. But first, I want to be able to differentiate between a downbeat and each subsequent beat. And then we'll have two different sounds for the downbeat and each subsequent beat. And we'll also be able to select the number of beats we want in a measure. Okay, so that's our mission for the day. And let's just quickly recap on what we've got here. We've got a basic metronome that you can turn on and adjust with the BPM, which in turn adjusts the millisecond value that goes to the metronome. Now, a couple of cool features. Anytime we load it, it automatically sets 60,000 as the left operand for the divide tool, which ensures that our BPM calculation will be accurate from the get-go. And this gate here means that when we adjust the BPM, it does not turn the metronome on, because if it were just passing directly here, it would. But it only immediately resets the metronome when the metronome is on. And to give you an example of why this is useful, at 20 BPM, if we were to adjust the BPM right after a blink, it would take 3 seconds for it to register. But with this little feature here, passing this bang through this gate into this left inlet, it's always going to immediately reset the metronome to the new millisecond value as soon as we adjust the BPM. Okay, so that's the recap. Let's dive in. The first thing we want to do is we want to count the beats that are coming out of our metronome. So we'll use a counter object, and I'll put a number box below just to display the output. Whoops. And let's see what happens when we turn on our metronome. All right, it's just counting up and up and up and up, and it's just going to go on forever in theory. But with a couple of simple arguments, we can turn the counter tool, or the counter object, into basically a looper. So I'm just going to drop them in here, and then we can open up the help file and take a look. But I've put in 3 arguments. The first is 0. This sets the mode, and this is by default 0. This is by default counting up. And then the second 2 arguments are the loop start and end point. So before I turn it on, predict what's going to happen. Well, it's going to count upwards. We know that based on this argument. It's going to start at 1, and it's going to end at 4, and then repeat from there. You can slow it down a little bit. Great. So that's working as intended. Let's just test it real quick. What if we get rid of this argument? Do we need it? It still works. Okay, so let's leave it at that. Counter with the start and end points of a loop. So I figure 1 and 4 is probably a good default, but the reality is we are going to want to be able to select the number of beats in a measure. Sometimes there's 3, sometimes there's 5. Shit, maybe there's even 7. Who knows if you're jazzy. So what we're going to do is we're going to take this and we're going to input it into the right inlet here, because that sets the count maximum. So I'll go ahead and connect that. And let's see if I type a 5 here, hit enter, and we turn on our metronome. We get a counter from 1 to 5. Let's type a 3. Okay, so even though we still have this argument in place here, this is ultimately going to override it. And good to start with a default that's common, much like we have 120 as our default here. 1 through 4 would be a great default for the counter. So we can go ahead and label this with a comment box. Let's call this number of beats. All right, and we'll probably want these in our presentation because we want that to be user customizable. And might as well switch this out at this point for a live numbox so that we can map it in the future if we wanted to. Okay, great. So that's all working as planned, and our output here, and we can get rid of this because this is kind of our new little tool here. Our our output at this point is just the beat number, but what we want to do is differentiate between beat 1 and all the subsequent beats. So to do that, we're going to use an if argument, or an if object. So it's a conditional statement. If this, then that. And we're going to go if inlet 1 is less than 2, then B. So what that means is if the number coming in here is less than 2, meaning if it's 1, since we're just working with whole numbers here, then send a B, a bang. And over here we can do if integer 1 is greater than 1, then B. And so this right here is basically going to split this up so that we'll see a bang on beat 1 on the left and a bang for any other beat on the right. Let's test it out. Number of beats, 4. Good. 1, 2, 3, 4. So let's just quickly stop and observe a couple of problems. This was set to 0, so we want to set the minimum value here. And you may have also noticed that it started blinking over here, right? Because this counter was, not at 1 to begin with. So we want to be able to reset that to 1 whenever we turn on the metronome, because we assume we want our downbeat to be the first thing to occur, right? Now there are a couple of ways we could do that. We could do some sort of bang to a message here. Set 1. I mean, I'm not entirely sure if this will work, actually. So humor me. Because like I said, I'm basically a beginner. Let's just see what happens when we toggle this on. Okay, it sets it to 1. Let's see if we stop at it. Yeah, anytime we stop it, it just goes to 1. Oh. Nope, it's not working. So that's not going to work for us. But conveniently, resets counter to number on next clock. That's going to be our inlet for making this functionality work as desired. So let's just incorporate that real quick. We're going to send a message 1. We're going to send it to resets counter to number on next clock, and then we're just going to take our output here, and we know that that's going to send a bang. And in theory now, anytime we turn on the metronome, let's take it nice and slow. Let's go to maybe 80. And we're going to turn it on. And then I'm going to turn it off to 3 on beat 3. And let's see what happens when I turn my metronome back on. Will it start at 3 or 4, or will it start at 1? It started at 1. And that's because this is sending a bang to set the counter back to 1. So anytime we toggle it on, I'm not sure if off also sends that or just on, but it doesn't really matter because it's working as desired. Groovy. Okay, so the only other thing we need to mess with here is setting our values here. We want to enable an initial value, and we'll say 4. And then we want to make sure that we have a suitable range. And where is that? Type. Float. We'll go with integer, and we'll go from 1 to 7. Let's do 12. Okay, so let's just double check this. We can go to 12. Maybe there's a 12/8 groove at where your quarter note, or I guess it would be your eighth note, would be kind of on the faster side. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1. Yep. Cool. So, I don't know. I would probably never go up to 12. I'd probably use 6 instead. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But there you go. That's taken care of. So it's time to move into Soundland. I'm going to go ahead and swap these out for live buttons because they're prettier. And then we're going to use these to trigger our sounds. All right, so I mentioned in the last video this Demystifying Max MSP PDF that I downloaded that taught me a lot rather quickly. And I've never really gotten into sound for plugins. I'm mostly interested in Max for its MIDI capabilities and stuff like this, taking data and using it creatively to work for me. So this is all from here on out just from that PDF, and I'm just going to walk you through the gist of what I learned. So to get started with audio, the first object we need is a buffer. And what this does is it pulls audio from your computer into the patch and buffers it, loads it into the buffer, so to speak. Now there are some arguments for this. How much you want to store. You can set a range in milliseconds. Not really relevant to us because we're going to be using very small samples, just click sounds. But the argument that we do want to add is what we're going to call it. So we're going to have two sound files. We're going to have sound file high, and then we're going to have sound file low. And regardless of what we load in here, within this patch, we can call it up or refer to it as sound file -high and sound file -low. So no matter what we change it to, whatever's in the buffer is from there on out going to be referred to by these names. So what we can do now is add a message, and the buffer object takes a read message. And watch what happens when we click this. Hey, it opens up the file browser. And you'll see here I've already created a little clave low metro, clave high metro. And we can do the same for the other one, and that will allow us to load our low sound file. Click here, load our high, click here, load our low. Okay, so in theory they're in there, but we can't really see whether or not that's the case, nor will we hear anything just yet. So we're kind of jumping the gun. And what I want to do is create a button for loading both sound files and just do it in sequence. So I'm going to create a message, a clickable button that says load sounds. And I guess I'll say high, then low. And we're going to start by sending a bang. So does this output a bang? Nope. So we'll use a button to convert that to a bang. All right, and now clicking this button will, initiate this sequence to load this sound file. And then check this out. Send bang when file read operation is completed. Well, what we can do is wait for that to complete, send a bang, and then have it automatically prompt us to load the next sound file. So let's see how this looks. Load sounds, high then low. Click it. High, then low. Boom, that was pretty cool. So now I've buffered the high sound and I've buffered the low sound. So what we can do now, just to have a little more confidence that they're in there, because sure, I guess I trust the computer, but I can't really see or hear any confirmation that they're in fact in the session. We can use the waveform object. Whoops. And this is basically just a little display UX thing, or UI, I don't know. I don't know what I'm talking about, but it takes a message, and we can tell it to set itself with sound file high. And now it's going to take that kind of internal nomenclature, and as soon as sound file high is finished loading, it'll send a bang here, and it'll load visually into this little editor. So I can move this out of the way. Oh, not seeing it. There it is. I'm not sure why that took a second to load. Maybe it was just because we were in the file browser. But there's our sound file high, and we can do the same for our sound file low. so that when that's loaded, it can also load in this little display. And then we can add these to our presentation, and that just gives us a little more confirmation in the plugin that we have in fact loaded both our sound files and the metronome should work. So we need this and we need this in our presentation, and these two while we're at it. Let's just quickly revisit presentation mode, see what we've got. Okay, number of beats. We're missing that guy. Drag these up here. We've got our blinkers. And then let's see, load sounds, high, then low. Can't say this is super nicely laid out, but I think we've got high here, is that right? Yep, high on the left. Like that. And then low. And so now we've got this kind of simple visual confirmation that our sound files are loaded, and then we've got our little blinkers here that are going to indicate the downbeats and the subsequent beats. I'm not sure what, they're not upbeats, what are they called? Downbeats and other beats? Anyways, the last remaining step here is to get some audio coming out of the plugin. And so this is, again, where I'm just going to draw directly from that Demystifying Max PDF. We need a line object with a tilde for audio, right? Because tilde means audio. Without a tilde, it means data. And what this does is it creates a signal ramp. And without this, I don't think it works, because this is just a necessary step in this particular language. Honestly, I'm a little confused about it still, but I'll show you what needs to be done. You need a line object, and you need to send that line object a message. And I'm just going to gloss over what these arguments mean, because I'm not clear enough on it to confidently speak to what's going on here. But it works great. We send this message to the line object, and then we create a play object, and we type in our file name. So we want to use a high sound for the downbeats. And then we can just copy all this over here for our other beats, except change this to a low sound. So now this bang, this blinker, this button is going to send a bang telling each time it bangs to create a very quick signal ramp to play this sound file. And then we need to amplify it. Multiply two signals, and we need to give it an argument of 1, initial multiplier. According to the PDF, anything above 1 will clip. So I think this just means play it at its intended volume. Okay? And that's basically all that's left, and we route this to the output of the plugin. Each beat can go... each sound can go left, right. Now there might be an argument in here for channels, would be my guess. But it should work as is, and I'm just going to leave it at that. So let's give it a shot here. Let's go into presentation mode. We've already got our sound files, but let's load them again. We got high, we've got low, and we've got a functioning metronome. Pretty cool. Let's just play around with it a little bit. Let's go 2 beats. Let's go 150. Let's go 4 beats. Amazing. Cool. And then you could swap out your sounds for something else if you wanted. But yeah, there you go. That went by pretty quick. That was basically everything I wanted to cover in this video. And that basically is where I'm at. I'm going to keep exploring with this stuff and make a follow-up video. Some of the things I'd like to do are set an 8th note – 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 8th no you know, a subdivision option, basically. So not really sure how I'm going to go about doing that, but it should be a fun process figuring it out. I did try one fun thing, which I might as well include here when I was playing around with this, where instead of a number box here, we use a live.menu. And I'm still not totally clear on how this works, but basically we want integers and, well, I changed this to 1, 2, 3, 4, 5, 6, 7. And so now we should see a menu with those 7 options. And then what it's going to send, I believe that's just the range. So what we can do is just put a number box below. Basically, this is just creating a drop down instead of a, slidey thing like this. So let's see what it sends when we select 1. It sends 0. When we select 2, it sends 1. So I'm not sure if this is a fault on my end, but there's a simple way to fix this so that it sends the appropriate number minus subtract 2 numbers, output the result. Oh, sorry, we want a plus, actually. So in the left side, we're going to set the left operand. And in the right side, we're just going to put it as an argument. So we're going to go +1. And basically this will convert this will, true up the output with what we see in the menu. So let's give it a shot. 1 beat. Right? We just see blinker there. 3 beats. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Interesting. But if I change this to 7, see how that's kind of messing with the counter there? It's like whatever measure you're in, it's automatically, gonna just immediately adjust the outer bounds to 7, right? So what we could do is anytime that this sends an output, we could bang this to reset to 1. So let's just try incorporating that. Get a cheeky little button here. And I'm going to route this here. We're going to route this here. And in theory, this should work. And we could do the same with this, routing this up here. But let's give it a shot. So we got 7 beats. As soon as I change to a new one, we want to hear an immediate high metronome. Yep. So not ideal necessarily. We're still hearing this right after, we heard it repeated a couple times, which is a little distracting or something. But whatever, just showing you how you can kind of work through these little conundrums and be like, how do I solve this? And there's always these clever ways to just kind of route something through, to hit reset or do whatever you need to do. So anyways, I'm going to wrap it up here because you can tell that as we wade into unfamiliar territory, I become a worse teacher. So there you go. That's pretty cool. That is a metronome, my friends. We'll see you at the next video. If there is a next video, I'm not sure. But I'm just going to keep playing around and learning, and I'm just going to try and share as much as I can as I go. So that's it. We'll catch you on the flip side.